So here's a question that's really at the heart of the entire AI revolution. Are these incredible large language models we keep hearing about just, fancy pattern matchers? Or is there something much, much deeper going on inside?
You hear this kind of argument all the time, and this quote just nails it. It's this idea that if we can explain the basic, simple mechanism, a bird flapping its wings or an LLM just predicting the next word, then we can just dismiss the incredible result. But is flapping your wings the same thing as understanding flight? Just keep that image in your head as we go through this.
All right, so let's start by digging into that simple explanation. What do people actually mean when they say an LLM is nothing more than a pattern matcher?
Okay, so this is the story you've probably heard 100 times. The idea is that an LLM is basically just a superpowered version of the autocorrect on your phone. It's been fed a gigantic portion of the internet, and based on all that text, it's just making a really good statistical guess about which word should probably come next. Simple, right? It just sees patterns and it repeats them. But this is where that simple story really starts to fall apart. Because if it were truly just a fancy word guesser, how on earth could it do things that seem to require some kind of real, genuine understanding?
I mean, just think about what these models are capable of today. They can work through complex math problems. They can analyze symptoms and help with medical diagnoses. They can write actual functional computer code. These things go so far beyond just guessing the next word. A simple pattern matcher shouldn't be able to fool a person into thinking it's human, but some of these models are getting incredibly close.
So if it's not just pattern matching, what in the world is going on? Well, let's try a little thought experiment. Let's see if we can get a better handle on this by comparing how an LLM learns to something we all know pretty well, how a human kid learns.
Okay, so on the one side, you've got how a person learns. It's this biological, messy, organic process. And on the other side, you have the LLM. Now, there are some striking similarities, right? It's trained on huge amounts of text, kind of like how we learn from books. And it adjusts based on feedback, just like a child being corrected. But the difference is, they are absolutely crucial. Its brain, its neural network, is fixed. And unlike a person, it can't just decide to learn something new on its own. Its entire life experience is just the data it was originally fed. It's definitely an engineered process, but you can't deny those parallels are pretty wild.
And this right here is where we get to the real mystery, the twist in the plot. Something truly bizarre and unexpected happens when you take that engineered learning process and you scale it up to a size that is almost impossible to comprehend. So what's the secret sauce? Well, think of it like a recipe for something else entirely. First, you take a mind-boggling amount of data, trillions of words and sentences. Then you build a model with billions, sometimes trillions of connections, or what they call parameters. And finally, you stack it all together in these deep, complex, nonlinear layers. When you mix all that together at that massive scale, you get something that researchers call emergent behavior. And here is the absolute craziest part. The creators, the people who built these things, they didn't program the LLM to understand how to write code or do advanced math. All they programmed it to do was predict the next word. But by doing that one simple task over and over and over again at an unbelievable scale, these other, much more complex abilities just show up. They emerge from the sheer complexity of the system, and frankly, even the people who build them don't fully get how it's happening. Okay, so this is where it gets really, really cool. Since we can't fully explain this stuff just by looking from the outside, scientists have started to figure out ways to actually peek inside the black box and see what's going on in the model's virtual brain.
Now, there's a whole field of science dedicated to this. It's called mechanistic interpretability, and it's basically a fancy way of saying that scientists are trying to reverse engineer these AI brains. They want to literally map out the internal wiring to figure out how an LLM actually represents an idea like truth or logic, or even a place like Paris.
And what they're finding is just mind-blowing. It shows just how far we are from simple pattern matching. They are finding individuals' specific artificial neurons that seem to fire only for abstract concepts, like if a sentence is deceptive or for the rules of grammar. They found what they call monosemantic neurons that light up for one single idea, like the concept of chess or the country France. And maybe most incredible of all, they're finding entire networks inside the main network that seem to function just like logical reasoning circuits. This isn't just mimicry, it's evidence of internal world models and structured thought.
So let's bring it all back to where we started. We have all this evidence now of these complex abilities, this emergent behavior, these internal structures that are actually representing real-world concepts. What does all that mean for our bird?
Look, the next time you hear somebody dismiss this technology and say, oh, an LLM is just predicting the next token, remember this. While that statement is technically true, it's also profoundly, deeply incomplete. Yeah, maybe predicting the next token is the flapping. That's the basic mechanical action that we can see and understand. But what the evidence is starting to suggest is that in order to flap its wings that well, at that unbelievable scale, the bird has to start building an internal model, a model of wind, of gravity, of lift. It has to, in some way, learn the actual principles of flight. And that leaves us with the real question here. Is it just going through the motions, or is it actually learning to fly?